In this video, I'm going to show you how to estimate products of both whole numbers and decimals. So we're going to start off with whole numbers. Let's say we have 348 times 7. When I'm doing magnitude estimates for multiplication, I always round to the greatest place value unless I have a particular context for my problem that requires me to be more accurate in my estimation. So in this problem, I'm going to start with my first factor, and I'm going to round to the greatest place value, which is the hundreds place. This number is closer to 300 than 400. And my next factor is a 7. Now, because I already know my multiples of 7, I'm going to leave the 7 alone, because I now have an extended multiplication factor that I can do. 3 times 7, which gives me 21. And I have 2 tens in my problem, so I'm going to have 2 tens left in my answer. So that my magnitude estimate is approximately 2,100. So let's look at another example. Let's say we have 8,429 times 56. I'm going to start with my first factor, and greatest place value is the thousands. So I'm going to round to the nearest thousand. In this case, that would be 8,000. And in my other factor, the greatest place value is the tens. This would round to 60. So my extended multiplication fact is 8 times 6, which is 48. And I have 1, 2, 3, 4 tens in the problem. So I'm going to have 4 tens in my solution. So my magnitude estimate is 480,000. Let's look at another example, this time using decimals. So let's say I have 256 and 96 hundredths times, let's do 23. And I want to find out approximately what is the product of these two numbers. Now, when I estimate this, I am not going to put any decimals in my estimate, because estimates are meant to be done quickly and mentally, and I don't want to even deal with multiplying decimals in my head. So in my first factor, the greatest place value is the hundreds, and 256 is closest to 300. My second factor, the greatest place value is the tens, and 23 is closest to 20. So my base problem is going to be 3 times 2, which is 6. And I have 1, 2, 3 tens in the problem, so I need 3 tens in my solution. My magnitude estimate is approximately 6,000. Here's another example with decimals. Let's say I have 429 and 57 hundredths, and I'm multiplying that by, let's do 19 and 25 hundredths. My first factor, the greatest place value is the hundreds. So this is closest to 400. Again, no decimal in my estimates at all, because I want to be able to do it mentally. My second factor, the greatest place value is the tens. 19 and 25 hundredths is closest to 20. So the base problem is going to be 4 times 2, which is 8. I have 1, 2, 3 tens in the problem, so I need 3 tens in the solution. And my magnitude estimate is approximately 8,000. So let's do one last example, this time giving our problem a context. And let's say at last week's high school football game that there were a total of 9,468 people in attendance. And let's say that each of those people paid a ticket price of, let's say they paid $8.50 for admission. So if we wanted to know approximately how much money was raised in selling tickets to this game, we can do a magnitude estimate here. So my greatest place value in my first factor is the thousands place, and 9,468 is closer to 9,000 than to 10,000. So that'll become a 9,000. The greatest place value in my second factor is the ones. So $8.50 is closer to $9. So I'm going to round it up to 9 than it is to 8. Notice again, I'm not putting any decimals whatsoever in my estimate. I don't want to multiply with decimals in my head. So my base problem of this extended multiplication fact is 9 times 9, which is 81. And I have 1, 2, 3 tens. So I need 1, 2, 3 tens. So going back to my original context, if I were estimating the approximate amount of money that they raised just by selling tickets to this game, it would be approximately $81,000.